over there. The question was saying, sorry, the question was saying a sodium hydroxide of solution or a sodium hydroxide solution is prepared by dissolving 4 grams of sodium hydroxide in water to make a 500 cubic centimeter solution. Okay, fine. Then they said calculate the concentration of sodium hydroxide solution. So the scenario of what is happening here, you know that sodium hydroxide is in solid state, okay? So they're going to mix it with water, and this water is actually distilled. This is distilled water. So it is the water that is in absence of any chemical reagents that can basically react. So it doesn't actually react with the base over there. So what they want for the first question, they want the concentration 10.3.1. To find the concentration of sodium hydroxide solution, you have the mass, you also have the volume of hydroxide solution or the sodium hydroxide. So to find the concentration, you can use this formula M over mv over there. And then your mass is 4. And then now your molar mass, your molar mass for sodium hydroxide is 40, as we did in the previous equation. And then 500 divided by 1,000, I think it's going to give us 0.5 over there. Yes, it must be 0.5. And then what answer do we get?
0.2 moles per
0.2 mole per cubic decimeters over there. Now, moving forward, another question comes. During titration, 12.5 cubic centimeter of sodium hydroxide neutralizes 25 cubic centimeter of sulfuric acid according to the balanced chemical equation. Now, in that solution of 500 cubic centimeters, they only took 12.5. You must understand this very well. They only took 12.5. So having taken that 12.5, it means that the concentration is still the same. Meaning, it's like you mixed a juice in a 5 liter over there. Once you mix that juice in 5 liter, you only took maybe a cup in that um juice. Meaning, concentration, the taste is the same. So the concentration will be the same. The difference will be only the volume. Get my point? Now, meaning our concentration, even on this question, will remain as 0.2 because we only took 12.5. The difference is only the volume over there. So now the question says calculate the pH. All right, fine. Calculate the pH of H2SO4 solution. Now, having done that, what you can simply do, or what you do in this case, you can come and use the formula of titration, because they said it's during titration. And then during titration, we know that Ca multiplied by Va, not Vb, I mean Va, is divided by Cb Vb is equal to Na over Nb over there. Now, having done that, this one makes your life simple, because the only thing that you need now is the concentration of your acid. Okay, because you already have the volume, 25 cubic centimeter of sulfuric acid over there, and then the equation is balanced, so you have everything. So what you can simply do, you can ask yourself, do I have the concentration of my acid? No, you don't know. You don't have it. What is the volume of the concentration? Is 25. So guys, for this one, for this formula, whether you convert or not, it doesn't matter. Okay, so I'm not going to convert. That's multiplied by 25, and then the concentration of my base is 0.2, and then the volume of my base is 12.5 over there. And then is equal to, what is the stoichiometric ratios for acid? It's 1. For the base, it's 2 over there. So when I simply multiply this to that side. So it's going to be Ca multiplied by 25, giving us, what is 0.2 multiplied by 12.5 multiplied by 1 over 2? Can someone please do this in the calculator?
1,3.
1.3 over there. And then you divide both sides by 25, then divide both sides by 25. That's going to be Ca is equal to, okay, cancel. What do we get?
0.05, sir.
0.05 mole per cubic decimeters. What is this concentration? This is the concentration of the acid, which is H2SO4 over there. I hope we are fine in that case. It means that now, having that concentration, I'm looking for the pH. That means I'm going to do what? To do that formula of the balanced formula of pH and water, H2SO, I mean the acid and water, plus H2O. This shall give me H3O plus SO4 2 minus. We have said this in the previous lessons, and then to balance, it's only putting 2's in that manner. Now, I'm going to make the relationship between the concentration of H2SO4 and the concentration of H3O plus. There's going to be H2SO4 to the concentration of H3O plus in that manner. And then that's going to be, the ratio is 1:2 over there. And then the concentration is 0.05. And then to the concentration of H3O plus. And then you just cross multiply. What is 0.05 multiplied by 2?
0.1.
That's 0.1 mole per cubic decimeters. And then you just simply go and plug pH is equal to negative log concentration of H3O plus, and then you simply say negative log 0.1, and then what is your answer?
1.
That's simply 1. That's how you get your pH. Or you can do the long method.